Hi everyone, I'm Animesh Chaudhary and today I will be walking you through my solution to the Atlan Release Management Challenge. This video covers how I would approach fixing two critical pain points in the deployment pipeline with the ultimate goal is reduce the time to production. Before I dive in, I want to emphasize that I have very limited knowledge about the Atlan specific code base and the release process. The solution I will be proposing would use common sense and first principle thinking rather than throwing around tech jargon. Sometimes the simplest approaches yields the best results. So yeah, coming to the problem. After analyzing the scenario, identify two major problems. First, we have a massive 100k Helm chart that takes several minutes to sync even for small changes. This creates a bottleneck for the engineers. They are just waiting instead of being productive, and hence it increases the time to production. Second, we have unreliable testing. The tests are flaky, time consuming, and they are inconsistent. This leads to increased manual testing and hence longer development cycles and hence more time to production, increases the time to production. So let me walk you through how I would approach fixing these problems. So, coming to the Helm chart problem, we have a massive 100k Helm chart. Even for small changes, the whole chart syncs. Isn't that not good at all? Can't we optimize it here? Thinking of that, for small changes, can we track those changes? We have something for that. Yeah, we have Git. So, what would be a quick solution for this? Thinking that we have a mono repo, assuming that we have a mono repo and we also use Git, we can write a simple bash script that checks for the Git diff and only redeploys what has changed. Rather than deploying the whole rather than syncing the whole chart, we can only sync the components of the chart that requires resyncing again. That is different. This will have a fallback that will do the full deployment when necessary. This isn't perfect, but it would immediately reduce the deployment times and the time to production also decreases. But there might be many exceptions here. So what would be a long-term solution here? So the long-term solution would be break up the Helm chart into logical components instead of a massive one chart. We will have a parent chart and we have many subcharts with each component. Something kind of like this. This is only a proof of concept. So this module approach would allow us to only process what has changed, make the code base more readable, and dynamically reduce the deployment time because we have different components now. So I have also read one more Medium article regarding this. Instead of using Helm to deploy, we can also use Crane. Uh, there are various ways to deploy a Helm chart: kubectl, Helm install, and Crane deploy. This is a very good article regarding that, but using a different software, I wouldn't recommend as of now. This requires more testing for the specific use case. So yeah, this can also work, but requires specific code base knowledge for this. So I stick to the stick to very simple changes as of right now. Coming to the crane flaky tests. So what are flaky tests? Testers produce inconsistent results with the same environment and nothing has changed. You run it again and again and they provide inconsistent results. So this is a major problem. How would we fix this? First of all, let's identify which are those flaky tests. We have to run them again and again and again. So we will identify which is the flaky test. So after identify the flaky test, we have to quarantine them. Temporary, we have to skip those tests. This might sound counterintuitive, but it would make the pipeline more predictable and there will be no probability there. It will be more consistent now. So what after that we have to fix those tests that are inconsistent. So what tests, why these tests are inconsistent? There will be many reasons for that. There can be race conditions, there can be time dependencies, there can be a state, there can be external API call. These all the things that can cause the test to be flaky. So we have solved this we have solved this for the short term, but now what is the long term plan? So for the long term, we have to rewrite the problematic test first with proper isolation. We have to introduce unit testing, and we have to write end-to-end test. And we should also have structured integrated test. I also read about the Atlin engineering blog. Um we are already Atlin is already using ring deployment that catches bugs early or on. So this can also very integrate well with the uh, ring deployment strategy. So I also have a wild idea about how we can fix the flaky test part. Think of this is a very wild idea. Uh, think of a system that sends the log files, the error log files, all the log files to LLM, and the LLM will identify the pattern and suggest fixes. This is an example of that your test has failed, something kind of like that. Sure, this is a very kind of like throw AI at your problem thing, but this is the idea that can also work. So coming to the high level system design of the application, this would look like this. We have ring deployment, we have the CI/CD pipeline, and we have the test frameworks, the end-to-end tests, the unit test, and the integrated test. So, what are the limitations to my approach? I don't have the specific code base. I only have the high level overview. So, and I don't have experience. I don't have experience with Helm chart at this scale. So these are the limitations that I have. I don't have expertise, but given the opportunity, I can work closely with the team. This is the bonus section. For observability, the key is making it obvious where to look when things go wrong, not drowning in data. For the REST API example, I would look where is the request is slow, is the API down, is there an external dependency that is down, does the API slow during a specific time of the day or during a specific user interaction, or this behavior is new or it is gradually worsening. And for cloud cost, I would tackle the disconnects between technical decisions and financial impact by making clause visible to the engineers with their workflow. Because engineers prioritize performance over costs. So yeah.